Einstein might be wrong, and that statement alone makes people uncomfortable. But here's the twist. Being wrong doesn't mean being useless. From childhood, we train to think in binaries, right or wrong, true or false, correct or incorrect. That works for daily life. But the universe doesn't work that way, because science is not a list of final answers. Science is a process of getting less wrong over time, and nowhere is this clearer than in physics. General relativity is one of the most successful theories ever created. It predicted black holes before we could see them. It predicted gravitational waves a century before we detected them. It explains why time slows down near massive objects, why light bends, and why GPS satellites would fail without relativistic corrections. That's not a weak theory, that's a masterpiece. And yet, general relativity breaks down. It can't merge with quantum mechanics. It fails at singularities. It can't explain dark energy, and it can't fully describe the beginning of the universe. So is it wrong? No, it's incomplete. And those two words are not the same. To understand why, imagine this. You're given a box of puzzle pieces, no image, no title, no idea what the final picture is supposed to be. You start connecting pieces anyway. Small clusters form, patterns emerge, and your brain immediately jumps to conclusions. Humans can't stop themselves. Then you find a strange piece. Transparent, curved, smooth. You hold it up and think, this looks like the handle of a glass. Reasonable assumption. You've seen glasses before, so you start building the picture around that idea. But then new pieces appear. They don't fit. No matter how hard you try, the picture refuses to cooperate. And eventually, you realize something uncomfortable. That handle wasn't part of a glass. It was part of something bigger. Something you couldn't imagine from a single piece. Here's the key point. The handle never changed. Only your interpretation did. That's exactly how physics evolves. General relativity is that handle. It describes gravity extremely well on large scales. Planets, stars, galaxies, the expansion of the universe. But when we push it beyond its domain, cracks appear. Not because it's wrong, but because we're asking it questions it was never meant to answer. This has happened before. Newton's laws weren't destroyed by Einstein. They were contextualized. At low speeds and weak gravity, Newton is still right. We still use his equations every day. Quantum mechanics didn't erase classical physics. It revealed its limits. Every major breakthrough in physics follows the same pattern. Old theories aren't discarded. They're absorbed into something deeper. So when general relativity fails at the edges of reality, that's not a crisis. That's a signal, a sign that we've reached the boundary of our understanding. Science doesn't move forward by being perfectly right. It moves forward by being usefully wrong. Each theory is a map, not the territory, and general relativity is one of the best maps we've ever drawn. It may not be the final picture, but without it, we wouldn't even know where to look next. And that's the real power of science. Not certainty, not absolute truth, but an ever-deepening understanding of reality